Now we're going to start talking about similar figures, which is basically dilations, but we're going to notice specific things about these shapes that stay the same or maybe change. So we're going to talk about like angles, and we're going to talk about sides in similar figures. So for similar figures, we start out by looking at this hippo. Which IMO is like similar or which is distorted? This one doesn't look right. It's like kind of squished, right? This one just looks smaller, but it looks the same. So this one's similar, just a smaller version, and it's the same picture. This one looks squished. It's not correct. So this one looks good. Looking at our shapes now, I want to show you some cool things. So using this button, you could get a ruler. So we just figured out in class, what's the length of A to D? A to D was 3.6. So we just filled in these side lengths. So then A to B, AD is 3.6. Mr. Sal, I'll get it together. And then A to D is 4. I probably could have just counted that one. Then let's go B to C, that's 5.1. And then C to D, need that, and that is 3.6. So we would do the same thing. What's E to F? 7.2. Oh, that was E to H. That's why that's wrong. EH is 7.2. Check your letters. E to F is 8. BC is FG. FG is 10.2. GH is 7.2. And then what do you notice about the sides of the similar figures? So for AB, it was 4. EF was 8. That's twice as big. 5.1 for BC, 10.2, that's twice as big. 3.6, 7.2, twice as big. 3.6, 7.2. So every side was multiplied by 2. They're all multiplied by the same scale factor. So the sides of similar figures are just multiplied by the same scale factor, and they're all multiplied by the same number. Let's look at the angles. So if we used a protractor here to map out or measure these angles, what we're going to notice is angle G is 21 degrees. Let's look at angle C. Angle C is also 21 degrees. So if we look, it might be 23, honestly. 22, 23. Let's see. So if we look, right, 22, that one was 22. The angles are the same. They are not multiplied by 2. Let's just double check with angle F here. Angle F, see how many degrees is angle F. Oh, this is, let's see. Angle F using this protractor. Let's see how many degrees it is. Angle F seems to be 101. Let's just double check angle B matches up with angle F. Let's just see if that's also 101. That one is also 101. So the angles are the same. So big ideas. The corresponding angles are congruent, or the matching angles are the same. 101, 101, 22, 22. But the sides are multiplied by a scale factor. So if this side was 4, this side is 8. So the angles stay the same. The sides are multiplied by the scale factor. That makes similar figures. So for our notes, similar figures. When we dilate a triangle or a figure, it creates a similar figure. This is the symbol for similar. Remember, congruent was when they were the same size. So now these are not the same size, but all the angles are the same. So we just have, they're kind of like each other, but they're not the same size. So similar figures have all the same angles, but are different sizes. The sides are multiplied by the same scale factor, and the sides are proportional. We'll talk more about that next class, but right now you need to know the angles are the same, and the sides are multiplied by the same scale factor.